Hello and welcome to Power-Drift. This is a series we call Simplified, where we take complicated automotive ideas and we break them down into simple bite-sized pieces that you can use in your life with motorcycles. Today we're going to talk about traction control, but before we do that, please do subscribe, hit the bell notification icon, and if you like this video, please do remember to like, comment and share it with your friends. So let's start with what is traction. Put your hands together like this and slide them against each other without putting any inward force, and that is a low traction condition and the hands slide quite easily. Put a lot of force in and suddenly doing this becomes much harder. And the reason is because now there is more friction and weight on top of friction, and that effectively is traction. The problem with motorcycles is that as we brake and as we accelerate, as we turn, we change the amount of weight on the tire, and that changes the amount of traction we have to play with. Great riders use this to their advantage and generate more traction by putting weight in the right place at the right time. But the problem is that the roads aren't predictable, which means you could be going into a corner which is a nice grippy corner, and suddenly let's say there's a stream of water flowing across. As you go into the water, the amount of friction available because of the water, which works sort of like a lubricant, is suddenly much lower, and if you have a very sudden throttle input or something, you can suddenly run yourself out of traction. And that is the opportunity for traction control to come and do its work. Now, if you think about it, we can't really control traction for the front wheel at all because we have no real electronic control inputs going to the front wheel. How the system works is actually quite simple. The motorcycle figures out if your rear wheel and your front wheel are rotating at speeds that correspond to each other. The most common way to do this today is because we have ABS, you have the slotted rings on the front rim and on the rear rim. Their job is to tell the system whether the wheels are rotating or not, and we can use that to tell the traction control system how fast they are rotating. And at most speeds, as you go through corners or whatever, the motorcycles will have a correlation between the front wheel and the rear wheel speed as long as traction is stable and secure. When these numbers starts to go awry, that's when the system wakes up and says, hey, there's something wrong. Now, a human being can maybe perceive this at the rate of say a quarter of a second or half a second or something, but a traction control system today can cycle through this 100 times a second or at 100 hertz, which means it can check whether the wheels are still rotating well 100 times a second and intervene long before you've realized there is a problem. That brings us to the question of how sophisticated is your traction control. And obviously, the more money you pay for a motorcycle, the more the chances that the manufacturer will give you a very sophisticated system. The less you pay, the more crude the system gets. The problem with crude traction control systems primarily is the smoothness of the intervention. So, if you were to go into a corner and suddenly open the throttle a lot, what do you think will happen to the motorcycle? It would get upset, right? There'd be a stability problem because you'd suddenly generate a lot of weight transfer. Your front wheel would suddenly have a lot less traction. Your rear wheel will have a lot more traction, and there is potential for problems here. This is the same issue that we have with traction control, except that traction control never adds power, it takes away power. But if I take power suddenly away, then I can cause an instability there, which is why early traction control systems were useful, especially if you hit sand or water suddenly, but they were not considered great rider aids because when they intervened, they created quite a drastic change in the setup. Modern systems use a lot more input. So the reason why complicated motorcycles today have IMUs is because an IMU adds to the data from the wheel speeds to tell you more about what the motorcycle is doing. So an IMU will tell you precisely what the, for example, lean angle is. It will tell you what the acceleration rate is. There's load data, which is how much throttle do you have open coming from other places. It will also tell you whether the motorcycle is yawing, which is rotating around the axis. If you put a line vertically through the motorcycle and I twist the motorcycle like this, that's called yaw. And there's a lot of data going into the sensor, which the software can process and decide what to do next. What a traction control system primarily does is cut power. Most of the time, it's either they cut fuel for 1 or 2 cycles, so the cylinder doesn't fire, so there is a lack of power, that's what you're looking for, or they cut the ignition spark, in which case, obviously, there is no power either, or a combination of these two are used together to create the sense of traction control. The amazing thing about traction control today is there are many motorcycles, including at the level of 650s, where you can barely feel whether the traction control system intervened or not. In fact, I remember doing some laps at the Curry Motor Speedway on a V-Strom 650. I was very happy with myself. It was when we reviewed the GoPro footage because we were filming that we realized how much the traction control light was on, because I just did not have a feeling that we had a lack of traction at all. These systems are so good now that the interventions are almost silent. And that's why when people say traction control makes riders poorer, I have a bone to pick with that. What traction control does is give you a safety net, and you don't always have to lean into the safety net if you don't want to. You can go quite fast on motorcycles before the safety net protects you from yourself. So, in sum, what a traction control system does is restore a slide. It's the software that is the magic, because the manufacturer has to figure out at what point, at what rate do I control the slide and bring it back in line so that you are still in control. The challenge of motorcycle traction control primarily is because the wheels aren't flat. So on a car, the wheel is flat, the tread pattern is flat, which means that no matter what you're doing, the circumference of the tire, which affects how fast it's rotating, doesn't really change. On a motorcycle, your tire profile is like this. So when the tire starts to lean into a corner, the actual diameter of the tire changes, the circumference you're actually using on the road changes, and that has to be factored into the equation. So a motorcycle traction control system is a little bit more complicated than a car-based traction control system. But fundamentally, what it does is detect a problem, which is a slide or a reason why the rear wheel is spinning up. On some of the larger motorcycles today, you have options of levels of traction control, and basically what that does is allow you a threshold, right? So if I were to be like the strict headmaster and I say any time the tire spins you have to intervene, motorcycles can become very difficult to ride, especially in slippery roads. And the example I'd like to give you is concrete roads in Mumbai. They are quite slippery, and if you have traction control set up really high, the motorcycle becomes really difficult to ride because it's constantly intervening. So when you choose a level, 8 or 10 is usually the most intrusive level, and when you get down to the lower numbers like 2 and 1 is the least intrusive, what you're telling the motorcycle is how okay are you with it sliding a little bit, and when should the system intervene. When you use the systems off-road, what you do is give the motorcycle a lot of leeway, because you might be using a slide to tighten a corner, or you are in a loose surface and it will spin a little bit, so having no spin at all can be disadvantageous. This is why motorcycle traction control systems that are designed to run on road surfaces and those that are designed to run off-road are very different in how they intervene and when they intervene. But fundamentally, they do the exact same thing. When the rear wheel starts to slide, they cut power and restore balance. Thank you so much for watching. That's all there is to know about motorcycle traction control. I invite you to find a motorcycle with traction control and use it. It doesn't intervene as often as you think. It doesn't make you a poorer rider. It just gives you a safety net that you can lean on if you're in trouble because of what you did or because the road surface changed suddenly without warning. Thank you so much for watching. This is Simplified. If you'd like to discuss this further, leave us a comment. If you'd like other topics to be covered here, do leave us a comment. As you can see, traction control, the other series we did on engine formats, they've all come from questions you guys have asked us. And like I promised, leave us a comment and we'll get right on it. Thank you so much for watching. This is Powerdrift. All I ask in return is you hit 4 buttons for me: subscribe, the bell notification icon, like, and share.